Hello my dear students, once again welcome back to our channel. I am your maths teacher CG ma'am. In this video, we are going to discuss about the relationship between the zeros and the coefficients of a quadratic polynomial and cubic polynomial. Secondly, we will discuss how to formulate a quadratic polynomial if its sum of the zeros and the product of zeros are given. Based on these two concepts, we will discuss exercise 2.2. Let us start, children. Okay, that means if alpha and beta are the two zeros of a quadratic polynomial. Why? Because a quadratic polynomial will have maximum two zeros because its degree is 2. Okay, so let it be alpha and beta. So x minus alpha and x minus beta are the factors of p of x, that is ax square plus bx plus c. Understood? Okay, so the sum of the zeros alpha plus beta is always equal to minus b by a. Okay, what is a, b and c? In the general form of ax square plus bx plus c, that is the general form of a quadratic polynomial. A, b and c are the coefficient of x square, b is the coefficient of x and c is a constant term. Okay, so see children, this alpha plus beta in terms of sum of the zeros, and what I have written in the RHS minus b by a, that is in terms of the coefficients. Okay, and this b is nothing but coefficient of x, okay, and a is coefficient of x square. And product of zeros alpha into beta, that is product of 0 is equal to c by a. C is the constant term and a is coefficient of x square. Both having the same denominator, that is a comes in the denominator of sum of the zeros as well as the product of zeros. Okay, I will explain this with a very simple example. Okay, I am taking an example, that is ax square plus 7x plus 12. This is a quadratic polynomial. Understood? See children, compare this with the general form, that is x square, that is the coefficient of x square, that is a is equal to 1, okay, b is equal to coefficient of x is 7 and c is equal to 12. Okay, how we will get the zeros of a quadratic polynomial? Let p of x is equal to 0, equate the given polynomial into 0. That means I am going to equate this into 0. Understood? Okay, and by splitting the middle term, I am going to get its factors, and so that you can easily write alpha and beta. Okay, that means the 7x is the middle term. Since the product 12, that is a into c, okay, that is ac is equal to 12 by splitting the middle term, and the middle term, the sum should be b, that is equal to 7. Okay, so the factors of the product, that is factors of product 12, that is I simply written by the symbol f. F of 12 indicates the factors of 12 to satisfy these two. Okay, if you take 1 and 12 are the factors of 12, but we will not get the sum of those factors will not be 7. And 2 and 6 also the factors, but we will not get the sum of 2 plus 6 is not 7. But if we take 3 and 4, we will get the sum as 7 and product at the same time we will get 12. So, the factors are 4 and 3. I am going to split this middle term with the factors, that is 7x as can be written as 3x plus 4x. So, x square plus 4x plus 3x plus 12 equal to 0. Why we are equating to 0 children? In order to get the zeros. Okay, that is the condition. For 0 you can equate p of x into 0. From these two terms, now we have 4 terms. Okay, we will have 2 groups. We can take the common from each group, that is from this we can take x as common. Okay, why? Because x square here comes 4x. Okay, so from these two terms x is common, okay, and divide x square with the x, you will get x and plus 4x divided by x is 4. Okay, and from the second group 3x plus 12, 3 can be taken outside. We can't take variable because this is a constant term. but 12 is a multiple of 3. So, if you divide 12 by 3, you will get 4. So, this x remaining in the first term and 12 by 3 is 4 equal to 0. See that this you will have the same factor with the first term and the second term. And in the next step, you can take x plus 4 as common and x plus 3 as common. And that can be equated to 0 because we are going to find out the zeros of the polynomial. And in the next step, each factor can be equated to 0, that is x plus 4 equal to 0 implies x is equal to this plus 4 come to LRHS, so minus 4, this is alpha, and beta. To get beta, you equate x plus 3 into 0. The second factor can be equated to 0, that is x plus 3 equal to 0, that is x is equal to minus 3, this is equal to beta. Now we are going to add, that is alpha plus beta. Okay, alpha plus beta, that means here we have alpha is equal to minus 4, that is minus 4 plus minus 3. This is alpha plus beta. Alpha plus beta is equal to minus 4 plus minus 3, that is equal to minus 7. Okay, let us compare the coefficients given. That means we compared and we have written a, b and c. So, what will be minus b by a? Okay, coefficient of x, that is 7 here, then this minus sign, negative b is negative 7 divided by a is 1, that is negative 7. So, what we have observed here children, that is sum of the zeros alpha plus beta is equal to minus b by a. Okay, that is what I said in the beginning. Okay, if we have a quadratic polynomial, sum of the zeros is always is equal to minus b by a. In the LHS we have written in terms of it's a sum of the zeros, and in the RHS we have written in terms of the coefficients. So this is the relationship between sum of the zeros with the coefficient. Next comes the product of zeros, that is alpha into beta. Alpha is minus 4 and beta is equal to minus 3. So, their product, that is alpha beta is equal to minus 4 into minus 3, that is minus 12. And what is C by A? Okay, we have seen that is alpha beta, alpha into beta equal to C by A. Let us verify. That is alpha is minus 4 into minus 3, that is equal to, we will get here alpha beta, this is plus 12, minus 4 into minus 3 is plus 12. Okay, so see children, here C by A, C is the constant term. What is constant term here? That is 12, and that coefficient of x square, that is A, that is 1. So 12 by 1 is 12. So here what we have seen, that is the product of zeros, that is alpha into beta, is same as after taking the coefficient, considering the coefficient C by A, both are same. That is product of zeros is equal to C by A. Idea is clear children. This is true for each and every quadratic polynomial. So this is the relationship between sum of the zeros and product of zeros of a quadratic polynomial. Next we are going to discuss about the relationship between zeros and coefficients of cubic polynomial. We know the general form of a cubic polynomial, that is degree 3. That is ax cube plus bx square plus cx plus d. This is the general form of a cubic polynomial, and its highest power is 3. So it will have 3 zeros. Quadratic polynomial 2 zeros alpha and beta. For cubic polynomial it will have maximum 3 zeros. So let it be alpha, beta and gamma. Okay, so how that sum of the zeros can be expressed? Alpha plus beta plus gamma. Okay, so alpha plus beta plus gamma, and when we compare the coefficients, okay, that can be equated to minus of b by a. Okay, and second one, see in ax square plus ax cube plus bx square plus cx plus d, here we will have 4 terms. Children, a polynomial of degree n, okay, will have n plus 1 terms. Being it is cubic, its degree is 3, so it will have 4 terms, 3 plus 1 terms. Okay, so there should be x cube term, x square term, x term, then comes constant term. Okay, so x cube, then x square, then x, then will be the constant term. Okay, so sum of the zeros alpha plus beta plus gamma equal to minus b by a, and in the third term, okay, this is third term, that is sum of product of zeros taken 2 at a time. See children, alpha, beta, gamma are the zeros. Okay, so product of zeros taken 2 at a time. I am taking product of 2 zeros at a time. So alpha into beta, and in the second term beta and gamma. Okay, so plus beta and gamma, and in the third case the first and the third zero, that is alpha gamma. Okay, how can we state this? Sum of product of zeros taken 2 at a time, and that will be equal to c by a. And for the constant term, that is alpha, beta, gamma, what is that? Product of the 3 zeros. Okay, in case of quadratic, alpha, beta only. Here it is 3 zeros, so alpha, beta, gamma into, okay, product is equal to minus d by a. Constant term divided by coefficient of x cube. Okay, see children, here minus, here plus, and here minus, that is alternate plus and minus sign. Okay, so this is all about the sum of the zeros, okay, and sum of product of zeros taken 2 at a time, and product of zeros of a cubic polynomial, that is minus d by a. Is it okay children? Okay, see, if we have these 3 zeros, how can we form a cubic polynomial? Okay, that is, here we have the equation, that is x cube minus alpha plus beta plus gamma into x square plus, I told alternative, plus and minus. Okay, here the first term positive, negative, now comes positive for x term. This is sum of product of zeros taken 2 at a time, alpha beta plus beta gamma plus alpha gamma, and variable is x. So x cube, x square and x term. Next comes, here the sign will be negative, okay, plus minus, that is alpha beta gamma. This is the way to form a cubic polynomial if we know alpha, beta and gamma. By factorization method, okay, you can easily find out the roots of the cubic polynomial, and after that you can form a cubic polynomial. This is the formula. But in the textbook, in exercise, that problems related to cubic polynomial, to form the cubic polynomial is not there. Okay, so you just understand how to form a cubic polynomial. This is the formula, that is x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus alpha gamma into x minus alpha beta gamma. Okay, but we have how to form a quadratic polynomial. Okay, if alpha and beta are given, or sum of the zeros and product of zeros are given. Okay, so in the same way we can formulate the equation for quadratic polynomial also. See children, see, since quadratic polynomial means it will have 2 zeros, that is alpha and beta. Understood? So this is the way, that is the x minus alpha and x minus beta are the factors of ax square plus bx plus c. Understood? And if you expand this, okay, term by term multiplication or using the identity, you will get it x square minus alpha plus beta into x plus alpha beta. X plus a into x plus b, the identity. Okay, x plus a into x plus b this is equal to x square plus alpha plus beta into, that is a plus b into x plus ab. So this can be written in the form x minus alpha, x plus minus alpha, okay, x plus minus beta. So you can easily reach into x square minus alpha plus beta into x plus alpha beta. This is the formula to write down a quadratic polynomial if we know sum of the zeros. What is alpha plus beta, children? That is sum of the zeros, and alpha beta is just a product of the zeros. You just substitute the sum and the product in this form so that you can easily reach into the answer. Or you can formulate that quadratic polynomial by considering the coefficients a, b and c. Get a, b and c by comparing. Okay, so you can easily get quadratic polynomial of this type or this formula, that is x square minus alpha plus beta into x plus alpha beta. Okay children, now we are moving to the exercise work. Now we are solving exercise 2.2, that is we have to find out the zeros of the quadratic polynomial and verify the relationship between the zeros and the coefficients. Okay, so we have 6 problems in this first question. Yes, that means if the given question, the given polynomial in its standard form, that is quadratic, that is ax square plus bx plus c, okay, you can definitely use splitting the middle term method. Otherwise, you can get the factors by taking the common factor or using any identities. Okay, so check whether the given polynomials are in standard form. Okay, but when you compare this with the coefficient, you have to definitely write that given polynomial in its standard form if that given polynomials are not in the standard form. Okay, but to get the factors, you can use either any one of the identities that is given. Okay, so let us move to the first problem, that is x square minus 2x minus 8. Okay, so in order to get the zeros, equate p of x into 0, p of x into 0. Okay, that is, see here x square minus 2x minus 8 is the given polynomial. That means that can be equated to 0, 2x minus 8 equated to 0. Understood? Okay, then compare this with the general equation ax square plus bx plus c. What is a in place of a? That is 1, a equal to 1, b is equal to minus 2 and c is equal to minus 8, constant term. Okay, we are using the splitting the middle term to get the factors of this given polynomial p of x. To get the 0, equate p of x is 0. Okay. So, children, here being this middle term minus 2x should be splitted. Okay, we are using this method. Okay, get the product. What is product AC? A means the coefficient of x square into constant term. Here that is 1 into minus 8, that is minus 8. And sum, this is the method, children. Sum is equal to, that is the coefficient of the middle term. What is coefficient of the middle term? That is here minus 2, that is b, minus 2. In order to get these two, what can be the factors of the product we got after multiplying a with c? You should consider the factors of 8. I simply write that to represent the factors f. Okay. So, the factors of 8 can be 1 into 8. 2 and 4, these are the factors. Okay, but which pair can be taken to satisfy this? Okay, 2 and 4, 1 and take, if you add their factors, you can't reach into minus 2. Okay, so I am taking the factors of 8 as 2 and 4, then only you will reach into the sum minus 2. Okay, so 2 and 4. Okay, and another very important point is, if one of the if the product is negative, here negative, one of the factor must be negative, then only minus into positive become negative. Okay, and the sum, if you take the sum, here the sum is negative and that negative factor will be the biggest factor. So listen children, if the product is negative, sum is also negative, among this which is the biggest? 4. So that factor will carries negative sign. So you have to split the middle term in this manner, that is minus 4x plus 2x. Understood children why I am giving a negative sign to 4? Because we should get to the product negative 8. Okay, and when you add sum, when you take their sum, that also should carry the negative sign. So negative sign goes to the biggest factor of it, that is 4x. Okay, negative 4x. So I am going to split, and there is no change for the first and the third term. Okay, so which implies x square minus 4x plus 2x minus 8 equal to 0. I didn't make any change for the first and the third term. And after splitting the middle term, make them groups, 2 groups. And you can take x square minus 4x. What can be taken outside? We can't take any of the coefficient because x square coefficient is 1. Now look into the variable x square and x. You can take the least power, that is x can be taken outside, and divide each term of this group with the number outside, the variable outside. X square by x is x, minus 4x by x is 4, and this plus 2x minus 8. From these 2 and 8, 2 is even, both are even, so 2 can be taken outside. Okay, and you can't take any of the variable because this is a constant term. So after taking 2 from 2x, 2x by 2 divide, then x comes minus 8 by 2. 8 by 2 is 4. Children, you will get to the same factor of this. Okay, of the first term carries x minus 4 as a factor. So here also, if your calculation is correct, this can be equated to 0 because we are going to find the zeros of the given quadratic polynomial. So in the next step, from these two terms, these are the term plus sign separate terms. Okay, x minus 4 is a factor common. This you can say x minus 4 here and here, and divide this. After taking this means you divide this term with x minus 4, x remaining. Okay, plus divide this term with x minus 4, so 2 remaining, equated to 0. That means x minus 4 equal to 0. Each factor can be equated to 0. Understood? That means alpha, in order to get the first value of x, that is alpha, x minus 4 equal to 0. That means x is equal to 4. When this minus 4 come to that side, so this is alpha. Second factor, x plus 2 equal to 0. That is x is equal to minus 2. 2 come to RHS, so this is beta. That means we have found the zeros of the given quadratic polynomial by using the splitting the middle term method. Next is we have to verify the relationship between the coefficients. Okay, so here the coefficients we already have written, that is a, b and c. Okay, so children, alpha plus beta. Okay, what we have seen that alpha equal to minus 2 and beta is equal to 4, isn't it? So that is equal to minus b by a, that is we explained the theory part. Alpha, sum of the zeros is equal to, in terms of coefficient, minus b by a. Okay, so alpha plus beta minus 2 plus 4. So this is equal to plus 2. Let us see what is in the RHS. Minus b by a, minus of minus 2, b is minus 2 itself, b itself negative, so its negative is positive 2. Okay, 2 divided by, okay, a is 1, so 1, that is 2, that is 2 equal to 2, that is hence we verified with the sum with minus b by a. Alpha plus beta is equal to minus b by a. Next is alpha beta, product of zeros, equal to c by a. Okay, then alpha into beta minus 2 into 4, this is equal to minus 8. And in RHS, c by a, what is c? Minus 8, and a is 1, that is minus 8. that is product of 0 is equal to C by A, and sum of zeros alpha plus beta is equal to minus B by A, hence verified. This is a sure question. Okay, this type of question can be asked for 2 marks. Okay, now we are moving to the second question. Okay, and in the second question we have also the given problem in the standard form, that is ax square plus bx plus c. 3 terms are there. Okay, quadratic polynomial, that means of degree 2 must have 3 terms, otherwise you have to include the missing terms. Okay, so in 4s square minus 4s plus 1, we can compare this with the general equation, okay, before factorization. So a is equal to 4, b is equal to minus 4, and c is equal to 1. Okay, and since the given polynomial in S, that is p of S, can be equated to 0 in order to get alpha and beta, that is zeros. Okay, so 4s square minus 4s plus 1 can be equated to 0. This is very important. For zeros, you can equate the given polynomial p of s equal to 0. Now we are going to split the middle term minus 4s by considering the product. It's very important, AC. Here A is 4 and C is 1, so product 4. So you should consider the factors of that product 4. Okay, to satisfy the middle term, sum should be minus 4. In order to get, when you add which all numbers, when you are adding, getting minus 4, and their product must be positive 4. So you have to take the factors of 4 as 2 and 2. Then look into the sign. See children, here the product is positive. Okay, that means, and sum is negative. When we are getting the 2 negative signs are adding, we are getting the sum as negative sign will be remaining, and negative into negative positive. Okay, so negative 2, negative 2. When you multiply negative 2 into negative 2, positive 4. Negative 2 plus negative 2, negative 4. Satisfied. So we are going to split the middle term. Okay, so 4s square minus 2s, isn't it? Then this middle last term, no change. Okay, I am going to split these 2 terms, not splitting, I am taking the common factors by grouping this as 2 factors, okay, 2 groups. So 4s square minus 2s, 2 and 4, so you can take 2, and variables also you can take s square and s, you can take s as common. To get the remaining terms, okay, divide 4s square by 2s, that is 2s, minus 2s by 2s is 1, and I told here this also having 2s minus 1 as factor. See children, this 2s plus 1, can we take anything common? Nothing is common other than the sign, or 1 you can take as common, because 2 can be written as 1 into 2, 1 and also 1 into 1. Okay, if I am taking 1 from these, minus 1, okay, so 2s, multiply minus 1 into 2, when you expand you should get these 2 terms, okay, and this plus, can we write this as minus, okay, and I have taken this minus sign, okay, so this minus sign, another minus sign remaining there, 1 by 1 is 1 itself, okay, equal to 0, a minus b, this is a plus b, okay. So from these 2 terms, plus and minus, separate the term, so this is 1 term, this is second term, this 2s minus 1 is a common factor, so I have taken outside. So divide you will get 2s and this minus 1. 2s minus 1 by 2s minus 1, minus 1 can be equated to 0. Step is clear children. Here minus, if you take outside, the sign will be minus, then only minus into minus comes plus. Okay. Now in order to get alpha and beta, each factors can be equated to 0. See children, here both are same factors, so you will get a same value for alpha and beta. But that case also you have to separately write alpha equal to that value and beta is also equal to that value. Okay. Let us see what will be alpha and beta by equating 2s minus 1 equal to 0, which means 2s, if you keep 2s, this minus 1 come to RHS with the positive 1 and s will be 1 by 2, 2 into s. So, that 2 come in the denominator when you change that LHS into RHS. That is this, when you equate this also you will get to 1 by 2. So, alpha equal to 1 by 2 and beta also when you equate the second factor into 0 you will get s is equal to 1 by 2. So, beta also 1 by 2. So, alpha and beta. Now, we are going to verify this zeros and the coefficients. Okay. So, alpha plus beta is equal to minus b by a. What is alpha? 1 by 2. Beta also we have seen 1 by 2. Okay. So, 1 by 2 plus 1 by 2, 1. Okay. So, this is equal to minus b by a. B is minus 4. So, it's minus 4 divided by a also 4. So, 4 by 4 is 1. Hence, verified the sum with minus b by a is verified. And product. Product is alpha beta. That is equal to c by a. C only minus b by a, but c by a is positive. Okay. So, 1 by 2 into 1 by 2 equal to 1 by 4, right? And what happens in the RHS? C by a. What is c? 1. And what is a? 4. So, 1 by 4 equal to 1 by 4. Hence, verified. This is all about the second question. Okay, now we are moving to the third question, that is 6x square minus 3 minus 7x. That is not in the standard form. After x square term, okay, the power of x should be in its descending order. So, the third term will be the constant term. So, this minus 7x should come as the second term. Okay, that is the rearrangement you have to do before splitting the middle term. That is, let p of x is equal to 6x square minus 7x minus 3. The reason is clear, children. The polynomial should always express in its standard form. Okay. Now, in order to get 0, you can equate p of x equated to 0. So, equated to 0. Okay. P of x equal to 0. Now, we can compare and we can write what is a, b and c. Okay. So, a is equal to 6, b is equal to minus 7, x coefficient of x, and c is equal to constant minus 3. We are going to split the middle term. All these three having 3 terms, that is standard form. So, you can apply splitting the middle term. Okay, if the given polynomial is not in the standard form, you can apply another method. Okay, by taking the common factor like that. Okay, so you can't apply splitting the middle term for that cases. Okay, so we have to consider the product AC. Okay, here A is 6 and C is minus 3, so negative 18. Sum equal to minus 7 minus B, that is coefficient of x. For that, what can be the factors of 18, positive 18? Okay, in order to get to the product 18 and the sum 7, okay, you can take the factors of either 1 and 18, 2 and 9, also 6 and 3. These are the factors of 18. But in order to get 7 as their sum, can we take 6 and 3? Even if the product is 18, but 6 plus 3 is 9. We can't take. Okay, so only 2 and 9. Okay, product is 18 and sum also 7 you will be getting. So, you can take 2 and 9. Okay, and one more thing, here the sign, consider the sign before split the middle term. Okay, before the splitting the middle term, minus 18 and minus 7, both are negative. Okay, so one of the factor must be negative and that negative sign goes to the biggest factor. Then only when you take the difference, that negative sign will remain in the sum. Okay, and product also negative into positive, negative. Okay, so I am giving the negative sign for 9. Okay, so based on that we can split this middle term negative 7x, that is 6x square, no change for first and the third term, minus 9x plus 2x. See the difference, 7x minus 7x minus 3 equated to 0. I am grouping these 4 terms into 2 groups and I am taking 3 as constants, that is coefficient, and from x square and x I am taking x common, 3x common, dividing 6x square with 3x, you will be getting 2x, 6 by 3, 2, x square by x, minus 3x by 3x, 3, x get cancelled. And here 2x minus nothing is common other than 1. So 1 can be taken outside. And 2x minus 3 equated to 0. Okay. Now also you can see there are 2 terms. 2x minus 3 can be taken outside. 2x minus 3 into, after taking 2x minus 3 you can take divide, 3x remaining, and plus 1. Okay, 3x minus 3, 3x minus 3 get cancelled, equated to 0. Okay, so in the next step children, we can equate each factor into 0. Okay, that is 2x minus 3 equated to 0, and from this 2x can be equated to 3 and x will be 3 by 2. Here 3x plus 1 equal to 0 and 3x is equal to minus 1, x is equal to minus 1 by 3. Okay, so 3 by 2 is alpha and let it be beta, that is minus 1 by 3 is beta. Point is clear children? Okay. Now we are going to verify sum of the zeros with the minus b by a. Okay. So alpha plus beta equal to minus b by a. So what is alpha plus beta? 3 by 2 plus minus 1 by 3. They are unlike terms. Okay, fractions to be added. Okay, that must be like. Okay, so by cross multiplication, 3 into 3 9 plus 2 into minus 1 minus 2 divided by 2 into 3 6. That is 9 plus minus 2 is 7 by 6. What happens in the RHS? Minus of b by a. What is b? b itself minus 7. So it's minus, that is positive 7, and a is 6, 7 by 6. So hence verified, we got 7 by 6 as their sum, that is alpha plus beta, and by comparing we got minus b by a also 7 by 6. Now the product of zeros, that is alpha beta equal to c by a, that is what is alpha? 3 by 2 into minus 1 by 3, that is 3 get cancelled. Okay, 3 by 2 and minus 1 by 3. 3 get cancelled, that means you get minus 1 by 2. What is c by a? C by a, that is minus 3 by 6. Okay, 3 in 6, 3 in 3 one time, 2 times. So that is minus 1 by 2, minus 1 by 2 is verified. So this is all about this third problem. Okay. Now we are solving the fourth question. Okay, that is 4u square minus 8u. Okay, this is not in the standard form. Okay, in order to factorize, it need not be in the standard form, but in order to verify that the relationship between the coefficients and the zeros, that polynomial must be 0 in the standard form. Okay, so while when I am doing the factorization, I am not making in the standard form, but when I am comparing, that should be in the standard form. Okay, so first I am going to factorize this. Okay, that means here it can be represented by, with the p of u, that is 4u square minus 8u. I am going to factorize this. Okay, that is, in order to get 0, you can equate this p of u equal to 0. Okay, that is 4u square minus 8u equal to 0. That is very important step, children. In order to get the zeros, you have to equate that into zeros. Okay. So from these two terms which can be taken constant. You see that which can be taken 4 and 8 multiples of 4. So 4 is the highest factor, can be taken outside. From the variables u square and u, you can take u, the least power. So after taking that u square, 4u square by 4u get cancelled, 4 get cancelled, u and minus 8 by 4 2, okay, that is u get cancelled. That can be equated to 0. So we got the factors of the given polynomial. So each factor can be equated to 0, implies 4u equal to 0 and u is equal to 0 by 4, that is 0. And when we are equating the second factor, u minus 2 equal to 0, u can be 2. So let it be beta and this can be alpha. So we have alpha as 0 and beta we got it as 2. Now we are going to compare. Okay. So children, while comparing, I already told you this should be in the standard form. Here the constant term is missed. So I just put in place of constant c, I added 0. Okay. So that there is no problem because of we just adding 0 means nothing. Okay. So children, a is equal to 4, b is equal to minus 8 and c is equal to 0. Understood? Here since this is not in the standard form, that is why I factorize without using splitting the middle term. Understood? Because if we use the splitting the middle term, 0 comes AC, because 0 a in 4 into 0 0 so how that can be splitted, and we can't reach into this, we can't split. Okay, so that is why I have taken the common factor and we got alpha and beta as 0 and 2. That point is clear, children. Okay. See children, in order to get the zeros of the polynomial, splitting the middle term is not the only method. Okay, you can factorize according to our convenience. Understood, children? Okay. So we have alpha and beta. Okay, now alpha plus beta equal to minus b by a. Okay, this is the comparison. Okay, that is sum of the zeros with the coefficients. So 0 is alpha, 0 plus beta is 2. Okay, and this is equal to minus b itself minus 8, so it's minus, so positive 8 divided by a is 4, that is 0 plus 2 is 2, 8 by 4 is 2. So we verified their sum with the coefficients. Then product, alpha beta equal to c by a, that means alpha into beta, that is 0 into 2 and c itself 0 by 4, a is 4, so 0, 2 into 0 and 0 by 4 is 0, hence verified. Thank you children, thank you for watching and supporting my channel. Thank you all.